Okay, so this webinar is going to cover the basics of setting up CDRouter to do TR69 testing with your device. It's going to cover just all the settings, all the basic settings you need to get CDRouter to run its ACS to accept connections from your device. And I'll cover a little bit about the tests that are available in CDRouter at the end. So what I'm going to start with here is this is assuming that everybody is familiar with CDRouter and getting a basic setup up and running, being able to run other non-TR69 tests. We're going to focus on IPv4. IPv6 with TR69 is supported by CDRouter and pretty simple. Once you have a basic IPv6 configuration in place, adding TR69 is simple. But this example, for this webinar, we're going to deal with the IPv4 configuration. So in CDRouter, a basic setup, you've got a WAN side and a LAN side. The LAN side is not required for TR69, so it is possible to test a TR69 device with just the WAN connected. So if you have what would be considered a LAN side TR69 device, you can connect that directly to CDRouter, but you would connect it to its WAN interface. So in this example, the LAN interface would be the LAN side of a gateway where you don't typically run TR69. The device's TR69 client would be on its WAN interface. And so this is the side that would be connected to the ETH2 interface in this example of CDRouter. So in a basic CDRouter configuration, all you really need to configure is the WAN mode, which tells CDRouter how to assign an address to your device and the addresses that you want to assign to your device. So once you have that up and running and assuming that you're comfortable with that and running other tests, you can we'll proceed on to add the settings that will enable TR69 and the ACS on CDRouter. So in CDRouter, in your config file, there is a section for TR69, the TR69 add-on. And the first test var that you'll see is the supports CWMP test var. This is the master switch. So you need to uncomment this and set it to yes. And you also need to configure an IP address for the ACS. These two settings will enable the ACS in CDRouter, and which it will do at the beginning of the test run and listen for connections from your device. Note that just like all of CDRouter's services, like DNS or NTP or its remote host, all of these services are considered remotely accessible. That means that they are not directly connected to the WAN link. So here in your WAN section, we've configured an IP subnet that connects the device directly to CDRouter's WAN interface. So the 202.254.1 subnet, we have .1 is CDRouter and .2 is your device. And so that's the subnet the CDRouter connects to or communicates with the device on. And any services like DNS or NTP or the ACS, they have to be remote with respect to this subnet. So they can't be within the same subnet address. You need to configure them. And by default, their addresses are configured on an outside subnet from this address range. So in this example, we've put, by default, here we'll put the ACS on an arbitrary subnet 6.0.0.1. So the device would reach this address by using CDRouter as its next hop, treating CDRouter's WAN interface as a next hop router to reach this address. You can assign a different address if you like. We're going to use this address just for this example. And those two settings are the only ones that are necessary in order to enable the ACS and to have it up and running. If you make no other changes, CDRouter will take on the default values that you see in this section here. So by default, it will run on port 80 using HTTP, and it will listen for requests over HTTP using digest authentication and the username and password that are given by the ACS default user and ACS default password. Those are the two pieces of information that it will authenticate any incoming requests from the device. So your device also will need to be configured with an ACS URL and a username and password that it will use to authenticate itself with the ACS, and I'll show you those settings in just a second. You can leave all of these test vars commented out and not make any changes to them, and CDRouter will work with these settings. If you want to customize any of these settings, feel free to uncomment that, and you can set a different username and password that matches the one on your device. You can these timers, the wait for inform timer. The wait for inform timer is a timer that CDRouter uses when it is waiting for a connection from the device. So if you need to lengthen this, for whatever reason, if you're in your network, the device is taking a long time to communicate with CDRouter, you can increase that. 2 minutes is a pretty long time, and it only kicks in when CDRouter makes a connection request to the device. Once that connection request is successful, this wait for inform timer will start. So I mentioned these briefly. So the ACS port is the port that CDRouter's ACS will listen on. The ACS transport is the protocol it will use. By default, it's HTTP, but if you want to do SSL or TLS connections with the ACS, you can set that to HTTPS and correspondingly set the port to 443, which is the default port for HTTPS connections. You can use a different port number, a custom port number. You can use that custom port number with either HTTP or HTTPS, just so long as your device is configured to use the same port and the same transport mechanism. You can configure the authentication to, by default, it's digest, but you can configure it for basic authentication, which is clear text password, or null, which is no authentication at all. So even if your device were to send authentication information, CDRouter would ignore it and just allow any connection from your device. And as I mentioned, the ACS default user and default password are the username and password that CDRouter will authenticate your device with. There is another, the two test vars at the bottom, the ACS CPE default user and CPE default password. That's the username and password that your device will use to authenticate the ACS when the ACS makes a connection request to the device. So that's in the other direction. So anytime the ACS needs to initiate a connection request, it will contact the device at the connection request URL using these two pieces of information to authenticate itself with. So once you have your CDRouter config in place, you'll also need to configure your device to match those settings. So this, typically, most devices will have a TR69 configuration section in either the user interface or in its own config file. And this consists typically of an ACS URL and a username and password combination. There may be some other settings beyond that, but the minimum you'll usually find are these three pieces of information: the ACS URL and username and password. So given the config file settings that we have here in our CDRouter config, we are going to configure the device that we're testing with settings that match. So we're doing regular HTTP connections on port 80, using QA Cafe as the username and QA Cafe 123 as the password, and the ACS is running on 6.0.0.1. So that To construct a URL out of that, you just combine all of that information into a URL minus the username. You can't include the username in the URL. So we're going to have http://6.0.0.1 and :80. Often you can omit the port number if you're using the standard port number. So using that ACS URL and the username and password, here we have an example user interface on a device where you would enter that information. So we put that URL into the ACS URL section and the username and password. In this example, we would also enable informs, and there's an inform interval for periodic informs, which you can enable as well. Many devices have periodic informs enabled by default. We often recommend that you disable periodic informs. This is not a requirement, but it's a recommendation so that the device you're testing only sends informs when they are requested by the ACS. This has the advantage of making your log files cleaner because you're not getting intervals in the middle of you're not getting inform messages received in the middle of your testing when they're not expected, which can cause confusion when trying to analyze your test results. And in some rare circumstances, there can be a condition where an inform is received when it's not expected, which may impact your test results. Again, it's not required. You can leave periodic informs enabled, and in most cases, CDRouter will handle them without any problem. But the basic settings that are circled here are just the ACS URL, username, and password. These settings need to match the test vars that we configured earlier in our CDRouter config. Once you enter this, I'm going to step back for a second. So in this example, we used a raw IP address in our ACS URL. We used the IP address of the ACS that ACS is running on. You can also use the host name acs.qacafe.com, and CDRouter will automatically resolve that name to the IP address of the ACS. That's CDRouter's DNS server that does that resolution. So if it receives a DNS request from your device, it will automatically translate it to the IPv4 address of the ACS. If you're running on IPv6 and your device sends a quad A DNS request for this same host name, it will resolve it to the IPv6 address of the ACS if you are running in IPv6 mode on CDRouter. So before I get to some test results, I'm just going to show, actually before I look at the other test vars, I'm going to show an example of what this might look like. So here we have a test log this is the start log that occurs at the start of every CDRouter test run. And it's going to collapse the sections down here. All right. So in every start procedure at the start of your test run, CDRouter first starts off by initializing the interfaces and its services that it runs on the LAN and the WAN. So you can see here, in addition to starting up DNS and NTP servers and its WAN interface DHCP server, it initializes TR69 just by setting up the ACS and getting it ready to be configured and receive connections. And then it sets its address and starts listening. This is before the device has its own IP address and can even make a connection. So once this ACS has been enabled, the WAN services are started. This is where the device requests an address from CDRouter's DHCP server. And we see this exchange happen here. Once the device has an IP address, it will typically do some other initialization, and part of that should be the device sending an inform to the ACS. Anytime the device is configured for TR69, any TR69 device is required to contact the ACS as soon as it is configured with an ACS address. So we recommend at the start of your testing to reboot the device, so that that guarantees that the device will try to contact the ACS. The reason I mention this is that if you don't reboot the device or somehow initialize it, it may be a long period of time before the device contacts the ACS on its own. So, and the CDRouter's ACS can't initiate a connection request unless you have configured a connection request URL properly ahead of time. So the simplest way to start your TR69 testing is just to reboot the device at the start of testing, which will force the device to contact the ACS. Once the device contacts the ACS, CDRouter will learn about the device and configure some additional parameters, such as it will configure the username and password for making subsequent connection requests to the device. This will allow the ACS throughout testing to initiate a connection request with the device and be properly configured. And as we'll see in a minute, when CDRouter receives an inform from the device, it also picks up the I'm going to go down to where we received. So once the initial TR69 parameters are configured, we see that we receive a post. The ACS receives a post from the device. This is the inform that is received from the device, and this is where CDRouter will learn about the device, its identification, and these two pieces, the serial number and the OUI together uniquely identify the device. This is what the ACS will use to identify this device. It will learn, in older devices, it will learn the device summary, which indicates which profiles are supported by the device. This is an obsolete test file, but CDRouter will still use it if it's provided. And most importantly, the connection request URL. This is the URL that the device advertises to the ACS, and it's what the ACS uses in order to contact the device whenever it needs a new session set up. So this URL, the ACS will automatically learn it and update its internal, it will cache it essentially and use it in whenever it needs to make a connection request in the future. In addition to that, CDRouter will configure the device with the username and password that will be used in the future when contacting this URL. So it will set parameters, as we'll see later on. I'm going to scroll down to the set section. This is just requesting basic. The CDRouter, the ACS will request some basic information about the device to learn about it, and then optionally it can perform some configuration on the device. So going back here, the wait for inform test var I mentioned earlier, this is how long the ACS waits to receive an inform from the device. You can force CDRouter to skip the initial inform. We don't recommend this because if you do skip the initial inform, the ACS will not be able to initiate a connection request to the device unless it is properly configured. And getting this configuration requires you to, if you skip the initial inform, then you'll have to make sure, let's go back to our inform. you'll have to make sure that the that CDRouter is configured with this exact URL, and also the authentication information, the username and password that go along with this URL. Often, as we saw earlier, the device's config settings don't include a way for you to configure the connection request URL or the username and password that go along with it. So skipping the initial inform is not recommended for that reason. So the skip initial inform and the ACS CP connection request URL, these are optional parameters that you can use if you absolutely need to. But usually the ACS will learn this automatically when it receives an inform from the device. So once CDRouter receives an inform and learns about the device, it won't take any other action. However, there is an ACS device discovery parameter. Enabling this will cause two things to happen. It will cause the ACS to disable periodic informs. This is what I mentioned earlier. It's recommended to disable the periodic informs so that you're not receiving informs in the middle of your testing when they're not expected. The second thing that enabling device discovery will do is it will set the connection request username and password on the device so that once the ACS has learned the connection request URL, it will also set the device's authentication parameters for that URL so that the ACS can make successful connection requests going forward. If you want to enable device discovery but not have it disable periodic informs, there's another test var, this ACS configure periodic inform. If you disable that, if you set it to no, then CDRouter's ACS will configure the username and password for connection requests, but it will leave periodic informs enabled. So all of those settings result in having the device make connections with the ACS over HTTP. As we see here, all of the connections come across in plain text, which you can see in the actual packet contents. So this allows you to examine the contents of the packets sent by the device if you're doing debugging. If, however, you want to have your device make connections to the ACS over SSL using HTTPS, you can set this up quickly with a basic TR69 configuration by changing the following two test vars. Set the ATS transport to HTTPS, and then by default, most devices will use the default port of 443 for HTTPS connections. So by setting those two test vars to match your device's configuration settings, you would make these changes in your config file, and then you'd also make the same corresponding changes in your device settings. So you would change that URL to HTTPS:// and then either the IP address or the hostname acs.qacafe.com. Optionally, you can set the port number to port 443. Most devices will use this port by default, but so long as the device is using the same port that you set using the ACS port, that's the port that the ACS will be listening on. So once you've set those two test vars and the device makes a connection to the ACS, it will initiate an SSL connection with the ACS. And by default, CDRouter's ACS will need to send a certificate file. The default certificate that's shipped with CDRouter is a VeriSign signed certificate, so it should be validated automatically by your device. You could find the certificate and the private key that go with it in the following file. It's designated by the ACS cert path And this you can find on your CDRouter system in this location, user share doc CDRouter acs.qacafe.com.pem. This is the PEM format is a text format that can be decoded. It's signed by VeriSign, as I mentioned, and you can find the root certificate on the CDRouter server as well. And you will need to load that root certificate into your device. Well, by default, for the VeriSign signed certificate, the default certificate should automatically be validated by your device. However, if you would like to use a different set of certificates, CDRouter does ship with a self-signed certificate that you can use, or you can use your own self-signed certificates. In order to use self-signed certificates, you simply need to upload the ACS certificate along with its private key in PEM format, and then update the ACS cert path test var with the location of that certificate. The ACS CA cert path indicates a file that contains any root certificate or intermediate CA certificate that would be used to validate that certificate. So if the ACS is sending its own certificate, and the signing certificate that's used to validate that certificate is not already loaded onto the device, you'll have to at least import the root certificate into the device. But any intermediate CAs that have signed, that are part of the signing chain, you can have the ACS transmit those to the device using the ACS CA cert path. In addition, there is a download cert path and download CA cert path. These are used by CDRouter's ACS file server. So for any tests that perform upload or download tests over SSL, the ACS will indicate a file server for the device to contact. This is a server that CDRouter sets up. It's a service just like any other of CDRouter services. The download server uses its own certificate file that can be found in the ACS download cert path file. By default, CDRouter will automatically negotiate the version of SSL or TLS using the best connection that is available as advertised by the device. So you can override this and have the ACS force a specific SSL or TLS version by setting the ACS SSL version test var. So the default value is SSL v23. This will cause the ACS to just negotiate the best connection it can. To force a specific version, you can set it to one of these 4 values, and the ACS will only accept connections at that version. This slide mentions what I mentioned a little bit earlier. If you want to use your own certificate files, you can substitute those certificates for the default ones that are used by CDRouter. The cert path just needs to point to the ACS certificate file. That file needs to contain both the certificate and the private key that go with it. The CA cert path contains the root certificate and any intermediate certificates that are needed to validate the certificate. That information will be sent across to the ACS, to the device during the SSL connection negotiation, but you have to make sure that also that your device has imported the root certificate so that the root certificate is seen as a trusted certificate for validating the connection. So going to our test results, we've seen that we received the inform from the device during the connection startup. And after requesting a bunch of information, CDRouter learns about the device and automatically detects the data model that's supported. So you see the device supports the Internet Gateway Root Data Model. If your device supports the Device 2 data model, which is defined on TR 181 issue 2, that would be indicated here. And then we go on to our testing. So once we get past the startup section, the TR69 tests begin running, and you'll see in any TR69 test, CDRouter will automatically connect to the device using the connection request URL that it learned during the start phase. So here we have the connection request URL. The ACS connects to the device and sends a GET to that URL. And once it is authenticated and we get an OK, CDRouter, the ACS then waits that wait for inform intervals. That timer starts to wait for the device to contact the ACS. And we see here we get a connection initiated from the device to send an inform. This allows so we have a new session set up and the test proceeds. So you can monitor these connections as the tests are running and use this information to diagnose and troubleshoot any test failures that you might see. So just briefly, I'm going to cover the tests that are available in CDRouter. TR69 is covered in 3 different add-ons that are available. The base, for any TR69 testing, you need the TR69 add-on available for CDRouter. This provides the ACS itself and a number of test modules to cover basic protocol testing in TR69. Included in that are the OD128 interoperability test plan. This was developed by the Broadband Forum during the development of the TR69 protocol suite, including CWMP. It covers basic functionality of the CWMP protocols, such as connecting to the ACS, authenticating with the ACS, handling basic requests for getting the parameter values and the parameter names, and doing set requests. There is also a TR69 module that we developed to supplement the OD128 test plan, as well as some data model verification of the root data models. In addition to the base TR69 add-on, there is an extended data model add-on available. This performs additional data model validation beyond the root data models. It tests the profiles that are available, such as the voice services or the voice services data model, and other extended data models that are available from the Broadband Forum. And lastly, the Broadband Forum has developed a certification test program. That program is a project of the Broadband Forum that provides certification testing conducted by test locations. The University of New Hampshire's Interoperability Lab is one of those locations. They actually use CDRouter as part of the certification testing in developing their own test scripts to conduct the certification testing. So the test scripts that they have developed are available within the broadband forum, or within the BBF.069 add-on available for CDRouter. So if you are interested in doing certification testing at the UNH Interoperability Lab, those test scripts that they will be using for certification testing are available in this add-on. Note that QA Cafe is not directly involved in the certification testing at all. They use CDRouter to perform the certification testing, and we've made those test scripts available through CDRouter. So the add-on, the profile testing that I mentioned previously, this verifies the root data models that are available with any TR69 device. So there are 3 different versions of the root data model. Initially, TR98 defined the Internet Gateway Device root data model. TR106 defined a device data model for non-gateway devices. That is an alternative root data model, so that a device would either support one or the other. The current version of the root data model, defined by TR181 issue 2, is the device version 2 data model that should be supported by all devices. In addition, the extended data model add-on for CDRouter provides data model service verification, or verification of the service data models that you see here. Voice services, set-top box, storage, etc. These are extensions to the root data model that may be supported by your device, and you can verify those with this add-on. Any of these data model verifications will provide generic tests to validate that your device supports the required parameters defined by any of these profiles using these 7 categories of tests. So, for example, it will request all of the required parameters using get parameter names at both the top level and at individual levels within the data model. It'll verify that the right parameter is set and that you can request a value for the required parameter and set a value using its current value. In addition to for any objects that can add or delete, that should be allowed to be added or deleted, CDRouter will attempt to create an object and delete an object. So all of these are just verifying the basic functionality. They don't actually verify the functionality that is represented by those objects. It's just to ensure that the device is supporting the required parameters. And you can see all of this in the any test package that you're creating under the TR69 add-on lists all of the modules that are available for you to add. And you can get an idea of all of the tests that are available and what the functionality they provide here in the package manager. We've also added some modules to verify that the ACS can configure wireless settings on the device. So this will attempt to configure the wireless settings for a variety of different security methods, and then validate that a client can connect to the device using those settings. So are there any questions at this point? This covers the basic setup and how to get up and running with TR69 on CDRouter. If there's anything you had further questions on, please feel free to ask or send us an email at support@qacafe.com. and we'll be happy to get right back to you and help you out with any problems that you might be having. Just real quick, I know I went over slides showing where your configuration information was. If you were to create a new configuration file, this is what it would look like. So that first section showed the WAN and LAN interfaces. This is where you do your basic configuration section, and hopefully you're already familiar with this. The CDRouter user guide will cover this information of how to get your WAN connection up and running. Once you've done that, you'll find the TR69 add-on section right here. So you can configure that. This is where you would set the support CWMP test var and set that to yes. Also where you would set the ACS IP address and any other parameters for the type of connection you want. Below that you will find the SSL configuration information if you're using SSL. CDRouter also supports XMPP connection requests. So this is, instead of using HTTP for connection requests, if your device supports XMPP, which is defined in Annex K of the TR69 specification, that can be configured here. So by default, CDRouter will use the connection request URL if it doesn't have any additional information. But if your device supports XMPP, you would enable that here by setting this test var to yes. Doing this tells the ACS, rather than looking for a connection request URL, to expect a XMPP connection from the device for the purpose of making connection requests. And you can configure the username and password here in this section for the XMPP server that CDRouter will initiate. There's additional timing and customization settings here in the ACS configuration section that you can use. This affects how the ACS is performing. We don't recommend changing any of these unless you need to. Unless you're having trouble with your ACS, you can use these to customize and fine-tune the operation of the ACS. We've had there was a quick question about the wireless testing that I covered recently. I'm going to go back to the package editor. So when I was, the TR69 wireless test module, this test actually verifies that the ACS can configure the wireless parameters of the device, and then it verifies that a client will connect using the wireless parameters that were set in the test on the device. So it does verify the actual wireless connection itself, and that the device, when it is configured via TR69 to use a particular set of wireless authentication and security options and settings on the LAN interface, that it does enforce those settings on the client, and that the client will not be able to connect unless it does so with these settings. CDRouter also has some tests to verify port mappings on the device. So we have a number of tests where the ACS will configure port maps on the device and verify that traffic is able to be forwarded from the WAN, matching and not matching, or matching those port mapping entries, and also that it blocks traffic that does not match those port map entries.